Retaining walls are used to hold back masses of earth or other loose material where conditions make it impossible to let those masses assume their natural slopes. Such conditions occur when the width of an excavation, cut, or embankment is restricted by conditions of ownership, use of the structure, or economy. Different types of retaining walls are used to retain soil in different places. The three main types of retaining walls are gravity, semi-gravity, and cantilever. The cantilever retaining wall is a reinforced concrete wall with small dimensions, and it is the most economical type and the most commonly used.
The cross-section of the cantilever retaining wall is shown below. Calculate the factor of safety against overturning and sliding. The specific weight of the soil is 15 kN per cubic meters and the specific weight of concrete is 24 kN per cubic meter. While the given angle of soil friction is 30 degrees and the coefficient of friction against sliding is 0.5. The total height of the cantilever retaining wall is 8 meters and its total base is 5 meters, while the top width of the stem is 0.5 meters. First, we will solve for the coefficient of soil pressure.
Solving for active soil pressure, we take CA to be 1 minus sine theta all over 1 plus sine theta. Theta is 30 degrees, so we will have an equation of 1 minus sine 30 all over 1 plus sine 30, which will be equal to 0.33. After solving for CA, we will now be computing for the weight of the retaining wall plus the soil. For weight 1, we have 5 times 1 times 24, which is equal to 120. Weight 2 will be 0.5 times 7 times 24, that is equal to 84. Weight 3 to be 1 half times 0.5 times 7 times 24, that is equal to 42. Weight number 4, which is 1 half times 0.5 times 7 times 15, that is equal to 26.5. Lastly, weight 5, that is equal to 3 times 7 times 15, that is equal to 315. Getting the summation for the total weight, that is W1 plus W2 plus W3 plus W4 plus W5, that is equal to total weight of 587.25. Finally, solving for a restraining moment, that is given as Rm equal to 120 times 5 over 2 plus 84 times quantity 0.5 over 2 plus 1 plus 42 times quantity 1/3 of 0.5 plus 0.5 plus 1 plus 26.25 times the quantity of 2/3 of 0.5 plus 0.5 plus 1 plus 315 times the quantity of 3 halves plus 1 plus 1, giving us a total restraining moment of 1,625.63 kilonewtons meter. Now, solving for active soil pressure, that is equal to CA times W times H, to be given as 0.33 times 8 times 15 equal to 39.6 times 8 over 2, giving us a value of 158.4 kilonewtons per meter.
Solving for the overturning moment. overturning moment is equal to 158.4, which is the active soil pressure, times 1/3 of the height, which is 8, is equal to 422.4 kilonewton meter. Now we solve for the factor of safety against overturning. So factor of safety is equal to 1625.63 over 422.4 is equal to 3.85. 3.85 is greater than 2.0. Therefore, it is safe.
Now, we take the coefficient of friction as we are going to use it in solving the factor of safety against sliding. Coefficient of friction is equal to mu times n, where mu is equal to 0.5 and n is equal to 587.25. Then, the coefficient of friction is now equal to 293.625. Now, let's solve for the factor of safety against sliding. Factor of safety against sliding is equal to the coefficient of friction over P. Remember that the minimum factor of safety should be greater than or equal to 1.5. Factor of safety is equal to 293.625 all over 158.4 is equivalent to 1.85. 1.85 is greater than 1.5, therefore, it is safe.